Hello, everyone. My name is Ashley, and today I will be arguing in favor of Apple's biometric authentication systems as a foundation for the future of cybersecurity. As our daily lives become more and more digital, the way that we protect our identities needs to evolve as well. Passwords are no longer enough to defend us from the growing wave of cyber threats, and there's no polite way to say this, but the password system is basically the equivalent of guarding a mansion with a shoelace. Apple's biometric systems, on the other hand, are built on Face ID, Touch ID, secure local processing, and this really represents the needed shift towards identity-based security that protects people in a way that passwords, honestly, frankly, never could.
Hello, my name is Kelly Pierre, and I'll be arguing against the reliance of Apple's biometric systems as a future of digital security. I agree that biometrics are convenient, but that convenience comes with serious ethical concerns. Face ID and Touch ID use data that is literally part of your body, which means that once it is compromised, you cannot change it the way you change a password. In my opinion, that makes biometrics a risky foundation for security. I will be using the deontology ethical framework, which focuses on duties and rules rather than just good outcomes. From that perspective, it is not enough for biometrics to be useful or efficient. Alright, Asha, I want to start with the big one. People hear the word biometrics and immediately think hackers, stolen faces, fingerprint theft in sci fi movies where villains hold your eyelids open. Why should anyone trust biometrics more than traditional passwords?
Well, that's completely understandable fear, and Hollywood is trained us to think that if someone steals your face, your whole life is over. But the truth is much less dramatic, but much more reassuring. So Apple never stores your face or fingerprint in any visual form. It actually stores a mathematical representation that lives entirely inside something called the secure enclave. And the secure enclave is a small portion of the phone's hardware that operates independently from the rest of the system. It cannot be accessed by apps, servers, or even Apple's engineers. It's basically the phone's version of a panic room, except it actually works. So when you scan your face or your fingerprints, the phone actually converts that information into an encrypted template and performs authentication entirely on the device. Nothing's ever uploaded to the cloud, nothing is stored on a server, nothing is shared with Apple. And if Apple servers were hacked tomorrow, the hacker would get exactly zero biometric data because it was never there to begin with. Passwords, on the other hand, can be guessed, stolen, leaked, bought, reused, cracked, or simply forgotten. So, biometrics solve a problem that passwords cannot because they eliminate the weak link in the chain, which is often, unfortunately, a human habit of making bad choices. To put it bluntly, the human brain is great for many things, but constantly and consistently remembering 15 complex passwords without repeating them is apparently not one of them.
But Asha, people argue that biometrics are permanent. If someone compromises your biometric data, you can't change your face or fingerprints. Isn't that a serious flaw in the entire concept? I hear what you're saying about the secure enclave and mathematical templates, and I agree that that's more sophisticated than just dumping a password on a server. But for me, personally, that doesn't make the permanence problem disappear. Even if Apple doesn't save an actual picture of my face or fingerprints, the template still has to be stable enough to recognize me every day. That means if an attacker ever figures out how to copy, reverse engineer, or reliably spoof that template, I'm stuck with having my biometric data compromised. While I can reset a password in 5 minutes, I can't replace my fingerprints, or my face for the rest of my life. From a deontological point of view, that's a huge red flag. You're building a security system on information the user can never truly replace.
So that sounds scary. That sounds scary. Until you look at how the system actually works. The permanence argument falls apart when applied to Apple's system because the thing that is permanent is your face, but the thing that Apple stores is not your face, so it's once again storing the scrambled encrypted equation that only your phone understands. So the fear that someone might steal your biometric identity sounds dramatic, but does not reflect how the architecture works in real life. If someone wants to break into your phone, they will have a much easier time guessing your dog's name than cracking an encrypted biometric template.
Alright, let's move into privacy, because that's where a lot of my concern lies. I agree with you that Apple's design storing biometric templates locally in the secure enclave instead of on some giant company server is better than a full-blown surveillance database. I even cite Apple's platform security documents in my paper to acknowledge that they aren't just being careless with the architecture. But being better than a terrible alternative doesn't automatically make something ethically safe enough to be the default. A mathematical template of my face or fingerprint is still extremely sensitive.
Okay, so this is probably one of the most important points to clarify because the word facial recognition has been misused so many times that people assume every single face-based technology works the exact same way. So what Apple does with Face ID is not the same as what governments do with surveillance cameras. Apple's not scanning crowds. It's not comparing people to databases of strangers. It's not collecting fingerprints or face prints. It is not analyzing video feeds. It's not building profiles of people. Face ID simply checks whether you match the encrypted template stored on your device. There's no communication with servers or databases. The system does not retain images or videos. Once the math is created for your face, the actual photograph is thrown away. Apple cannot use Face ID to track you, and neither can anyone else. But on the other hand, surveillance systems, those rely on centralized databases, so things like remote processing, massive image repositories. Apple system does the opposite. It's local, isolated, completely disconnected from any network. In a world where technology often does too much, Apple's biometric system is refreshingly limited on purpose. It's like the one overachiever in class who finally learned boundaries.
Let's tackle the bias issue more directly. You're right, the Face ID's depth mapping is more advanced than older flat 2D camera systems, and that's an improvement for sure. But research on facial recognition is still generally showing high error rates for people of color and for women. And my paper points out that these systems don't perform equally well for all bodies. In practice, that means some people are more likely to be told, nope, that's not you, even when it is them. Then they get locked out more often, or they have to fall back on passcodes. Others may not even be able to use Face ID comfortably at all because of facial differences, injuries, or religious coverings. From a fairness perspective, that's not just a minor technical bug, it's an ethical problem. If people who already face discrimination offline are also the ones more likely to be treated as unrecognizable by their own devices, how do we justify making biometrics the main gatekeeper of digital access?
So, bias accuracy, what Apple does differently. Okay, so this is a valid concern. In many facial recognition systems, especially older ones that rely on two-dimensional camera images, those systems often struggle with darker skin tones and non-standard light conditions, but Apple designed its systems to avoid those pitfalls. Face ID uses infrared depth mapping, which projects tens of thousands of invisible dots on your face to build a three-dimensional model. Since the system relies on depth and structure rather than color and lighting, skin tone plays almost no role in accuracy. Multiple studies show that these depth-based systems dramatically reduce demographic error gaps. Apple's second generation neural engine improved accuracy even further, to the point where false rejection rate is nearly identical across racial and gender groups. This is not a system that tries to guess who you are from the crowd. It's a system verifying that you match yourself. It's also worth mentioning that most biased facial recognition systems are large-scale surveillance models because poorly curated data sets scrap the internet. Apple's system uses no data set of strangers at all because it's only comparing your face to your own encrypted template. This eliminates the source of most algorithmic algorithmic bias entirely.
Let's bring ethics into this. You frame your argument using utilitarianism, maximizing overall good, and I get why. If millions of people are safer and have an easier time logging into their phones, that sounds like a huge win. But deontology asks different questions. What rules are we building into the system? A rule like it's okay to base security on a permanent body data as long as it helps enough people would worry a deontologist. It risks treating individuals as a means to the overall good rather than individuals. In my paper, I argue that a better rule would be something like we should not make someone's long term safety dependent on data they can't revoke, reset, or fully understand. So even if biometrics reduce some form of cybercrime, doesn't your utilitarian defense still leave us with an ethical rule that it's hard to justify if we care about autonomy and the right to take things back?
So the utilitarian perspective. Utilitarian is the idea that an action is morally right if it produces the greatest amount of good for the greatest number of people. When we apply this to Apple's biometric systems, the benefits are clear and very broad. Biometric authentication prevents an enormous amount of harm by reducing the likelihood of identity theft and unauthorized access. It helps millions of users secure their data more effectively than traditional passwords. It improves accessibility for people with disabilities, creates fewer burden for elderly users, and reduces the overall cognitive load on society. In contrast, the harms are minimal because Apple's system is intentionally designed to avoid intrusive data collection. way improve security, the reduction in cybercrime, and the increased usability and the ethical protections, embedded in the system. The utilitarian conclusion is fairly straightforward. The benefits dramatically outweigh the risks, creates more positive consequences for more people than the alternatives do.
A lot of people watching this are probably wondering about accessibility, and I'll be honest, I think that's one of the strongest arguments on your side. For users with mobility challenges, tremors, memory issues, or chronic pain, typing long, complex passwords isn't just annoying, it can be a genuine barrier to using technology. But in my paper, I argue that the real benefit here is low effort logins, not necessarily face prints, and fingerprints themselves. There are other ways to make security accessible. Short but strong device codes, passwords, passkeys, hardware tokens, and voice control can all be designed to minimize effort without tying the system to immutable body traits. And even with biometrics, the experience isn't actually equal across all users. Some people are misrecognized more often, some can't even use the feature comfortably because of cultural or physical reasons, and some are pushed back into secondary passcodes anyway. That suggests that accessibility, as it is currently implemented, is partially dependent on how closely your body matches what the system expects.
As for accessibility and social inclusion, this is one of the areas that also doesn't get that much attention. Biometric authentication is extremely important for people with mobility challenges, cognitive impairments, limited vision, tremors, arthritis, conditions that make typing difficult, etc. Like, think about how many steps it takes to enter a strong password. You need memory, fine motor control, accuracy. Many people, this is a major barrier. Face ID removes all of that. Simply looking at the phone unlocks it. Touch ID offers a very quick alternative for users who cannot rely on facial recognition. Apple also provides options like voice control, haptic feedback, and flexible passcode settings. This entire ecosystem creates a more inclusive digital experience. And accessibility, once again, is not an issue. Millions of people depend on these systems. Biometric authentication comes with the independence and ease of use that these traditional authentication systems simply cannot offer. It transfers security from being a burden to something effortless.
Some critics say biometrics makes people lazy about security, and I wouldn't phrase it as lazy, but I do think they put people on security autopilot. When the login process is just look at your phone, it becomes so smooth that most users stop thinking about what's actually going on behind the scenes. They're more likely to type agree on updates, more likely to trust whatever's labeled secure, and less likely to question how their data is stored or what the long term effects and risks are. From a deontological perspective, that's tricky. Good security shouldn't depend on people reading every fine print paragraph, but it shouldn't quietly nudge them into surrendering permanent data under a soft blanket of convenience and marketing language. We're supposed to respect autonomy, not gently work around it.
As for the human error problem, human laziness is not a bug in the system, it is the system. People always choose convenience over security when forced to choose. Biometrics solves the problem by aligning security and convenience instead of making them compete. We know that human error is the leading cause of data breaches. People reuse passwords, they fall for phishing, they write down logins on sticky notes, or choose passwords like I love pizza 123 because they want something easy. Biometrics removes this entire category of failure. They strengthen security without requiring people to suddenly become cybersecurity experts. But convenience does not weaken biometric systems. Convenience is the entire point. It ensures that security remains strong even when human behavior is not.
Let's shift into the future. I completely agree with you on one thing. The just teach everyone to make better password strategy has been failing for decades. Humans are predictable and attackers know that. But I don't think that our only means are to turn our bodies into main keys for everything. In my paper, I talk about multi-factor authentication, strong device passcodes, passkeys, and hardware security tokens as alternatives that balance the ease of use with something crucial. You can replace them if something goes wrong. These methods still give you strong security and can be integrated into accessible workflows without tying your entire digital identity to data you can never change. So, why should biometrics be treated as the inevitable future of security instead of one optional layer among several tools that are strong and convenient?
As for the future cyber landscape, whew, I wish we could teach people to make better passwords. We've been trying for decades. The results speak for themselves. People still repeat passwords, still fall from phishing, and still plug their credentials into fake websites. Cyber threats are evolving faster than human behavior can adapt. Phishing attacks are automated by artificial intelligence. Password cracking is faster than ever. Credential stuffing attacks allowed billions of leaked passwords being circulated globally. But, but, biometrics solves this problem by removing the need for passwords entirely. Identity-based authentication aligns with how cyber threats actually work today. Attackers can steal a password, but they cannot easily steal your face through an encrypted mathematical model stored in an offline hardware vault. The future of cybersecurity will involve context-based authentication, environmental sensing, behavioral analysis, and multimodal biometrics. Apple's already paving the way with secure enclave architecture and privacy-preserved data processing. Password systems cannot compete with the speed and intelligence of future cyber attacks, but biometrics can.
Before we wrap things up, is there anything you want to say directly to the viewers who are still unsure? I want to zoom out for a second for the people watching. This isn't just about unlocking a phone in 2 seconds. It's about what kind of security norms we want to build our digital lives on. If we normalize the idea that our bodies are just some convenient login token, it gets much harder to push back when companies or even governments want to use that same data for profiling or surveillance. So what would you say to convince them that trusting Apple's system today will quietly open the door to more invasive uses of tomorrow?
So, to address the audience, if you are still hesitant about biometrics, think about this. Every major data breach that makes the news involves what? Passwords. Every dark web marketplace is filled with passwords. Every major cyber threat relies on passwords. They were the weakest link, they have been for decades. Biometrics, well, they're not perfect, but they are significantly more secure than traditional authentication. They reduce the risk of identity theft, improve accessibility, protect privacy, eliminate password fatigue, and they just create a safer digital experience overall. Apple Systems in particular was built with privacy as its foundation. It was engineered to prevent the misuse of biometric data, not enable it. And when you compare the harms caused by passwords and the protections provided by biometrics, the difference is night and day. In conclusion, Apple's biometric authentication systems represent a crucial advancement in both security and accessibility. They reduce the risk associated with human-based breaches, protect user privacy through local processing, minimize human error, and provide a more inclusive digital experience. Under a utilitarian framework, the societal benefits of biometric clearly outweigh the minimal risks, especially when implemented responsibly. So cybersecurity is not optional. Privacy is not optional. In a world filled with evolving digital threats, relying on outdated password systems is like using a spoon to defend yourself in a sword fight. Biometrics push us into a future where our identities, not our memory of passwords, keep us safe. Thank you.